day to everyone. This time, I'm going to discuss factoring by greatest common monomial factor. And this is Math 8 first quarter. But before I proceed, if you think you will learn a lot in this video or it will help you to do your mathematics module, please do subscribe, like and share, and hit the notification bell for the incoming videos. Factoring by greatest common monomial factor. Steps in factoring monomials or polynomials. Now letter A, determine the number of terms. Letter B, find the greatest common factor of the numerical coefficients. Letter C, find the variable with the least exponent that appears in each term of the polynomial. It serves as the greatest common factor of the variables. And letter D, get the product of the greatest common factor of the numerical coefficient and the variables. It serves as the greatest common monomial factor of the given polynomials. Letter E, find the other factor by dividing the given polynomial by its greatest common monomial factor. And the last, write the final factored form of the polynomials. Example, x squared plus 2x. First is determine the number of terms. In this example, we have two terms, x squared and 2x. Step letter V, find the greatest common factor of the numerical coefficient. If it is numerical coefficient, it means numbers of the terms. In x squared, the numerical coefficient is equal to 1. And in 2x, the numerical coefficient is 2. And the greatest common factor for number 2 is 1 multiplied by 2. Letter C, find the variable with the least exponent that appears in each term of the polynomial. It will serve as the greatest common factor of the variables. So from this example, the greatest or the least exponent that appears in each term is only x. We have two variables, x squared and 2x. And the least exponent that appears is only x. So 2x, then the least exponent appears in variable is x. Letter D, get the product of the greatest common factor of the numerical coefficient and the variables. So our greatest common monomial factor of the x is equal to x, and find the other factor by dividing the given polynomial by its greatest common monomial factor. For x squared divided by x, it is equal to x, and for 2x divided by x is equal to 2, and we have the final factored form of the polynomial x squared plus 2x is equal to x multiplied by x plus 2. We will just combine the product of greatest common factor that we got and the product by dividing the given polynomials by its greatest common monomial factor, which is x and 2. Since our sign is positive, the sign of x and 2 is also positive. Number 2 example, 7p squared plus 7p. So again, determine the number of terms. We have two terms, 7p squared and 7p. Letter B, find the greatest common factor of the numerical coefficient. We have the same numerical coefficient, which is 7. So greatest common factor of the numerical coefficient is 7. One multiplied by 7 for 7p squared. And for 7p, it is equal to 1 multiplied by 7. Letter C, find the variables with the least exponent that appears in each term of the polynomial. It serves as the greatest common factor of the variable. So again, the least exponent that appears in each term is only p. 7p is p. Letter D, get the product of the greatest common factor of the numerical coefficient and the variables. We have 1 multiplied by 7 multiplied by p is 7p. And the last is find the other factors by dividing the given polynomial by its greatest common monomial factor. 7p squared divided by 7p is equal to p. And 7p divided by 7p is equal to 1. And therefore, our final factor form of the polynomial is 7p squared plus 7p is equal to 7p multiplied by the quantity p plus 1. The same as what we did in first example, we multiplied 7p by combination of p and 1, and since the sign here is positive, the sign also of p and 1 is also positive, and the final factor form of the polynomial is 7p multiplied by quantity p plus 1. Number 3 example, 5x squared minus 10x cubed. If you will analyze this example, 5p squared minus 10x, so the first step is, so in this example, 5x squared minus 10x cubed, we have two terms. And step A is find the number of terms, and this is 5x squared and take 10x cubed. Then find the greatest common factor of the numerical coefficient. For 5x squared, it is 1 multiplied by 5. And for 10x cubed, it is equal to 1 multiplied by 2 multiplied by 5 multiplied by 10. Or the factor of 10 is 1 multiplied by 10 and 2 multiplied by 5. So we have 4 options of the factors of 10. Letter C, find the greatest common factor or the least exponent of the variable, and we can find it in 5x squared because the other term is 10x cubed, so our least exponent factor of the variable is equal to x squared. And then the next is we will divide the polynomial, or we will multiply the greatest common factor of numerical and the greatest common factor of variables, and it is 1 multiplied by 5 multiplied by x squared, and it is simply equal to 5x squared. By the way, in getting the greatest common factor of the numerical, we will find which numbers are the same in both terms. And in this example, we have 1 and 1, and then 5 and 5. So that is the greatest common factor for numerical coefficient of this example. And our greatest common factor is 5x squared. And we will divide the given polynomials by dividing by the greatest common factor. 5x squared divided by 5x squared is equal to 1. And 10x cubed divided by 5x squared is equal to 2x. And we will combine the greatest common factor 5x squared and the combination of 1 and 2x for the final factor. And we have this 5x squared minus 10x cubed is equal to 5x squared multiplied by 1 minus 2x. Again, we adopt the sign of the 10x cubed for the combination of 1 and 2x. Example number 4, 18xy plus 3y. If you will notice, 18 is divisible by 3, and we have y as variable with on both terms. Therefore, but before we are going to that step, the first step is take the number of terms, which is 2, 18xy, and 3y, and letter B, take the greatest common factor of the numerical coefficient. For 18, we have 1 multiplied by 18, 2 multiplied by 9, and 3 multiplied by 6. And these are the possibilities factor of 18. And for the 3y, numerical factors of this term is 1 multiplied by 3, and the least exponent of variables is y, and we will divide we will take the product of the greatest common factor of the numerical, and that is 1 and 3 by least exponent factor, the greatest common factor or least exponent of the variables, which is y. Therefore, the greatest common factor is 1 multiplied by 3 multiplied by y, or equal to 3y. And we will divide the given polynomials by the greatest common factor 3y. 18xy divided by 3y is equal to 6x, and 3y divided by 3y is equal to 1, and we will combine 6x and 1 and multiplied by 3y, the greatest common factor. And 18xy plus 3y is equal to 3y multiplied by 6x plus 1. Again, we adopt the sign of this 3y as the sign of 1. Next example is 5x squared y cubed plus 55xy cubed. Again, we have two number of terms, 25x squared y cubed, and we will take the numerical coefficient of this 25, 1, the possible common factor of 25 is 1 multiplied by 25 and then 5 multiplied by 5. And for 5x xy cubed, it is equal to 1 multiplied by 55 or 5 multiplied by 11, and we have the same factors for both terms as 1 and 5, and we will take variables or least exponent of variables, which is x and y cubed. Therefore, our final factor, greatest common factor is 1 multiplied by 5 multiplied by x multiplied by y cubed, or equal to 5xy cubed. And then we will take the product of the quotient of each term for this factor 5xy cubed. 25x squared y cubed divided by 5xy cubed is equal to 5x, and 55xy cubed divided by 5xy cubed is equal to 11. For our final factor is 25x squared y cubed plus 55xy cubed is equal to 5xy cubed multiplied by 5x plus 11. Again, we just copied the greatest common factor of numerical and variables, and we multiplied it by the combination of 5x and 11 by adopting the sign of 55xy cubed. So we have this final answer as 5xy cubed multiplied by the quantity 5x plus 11. Example number 6. 15t cubed minus 15t squared plus 20t. Now in this example, we have three terms: 15t cubed minus 15t squared and positive 20t. For 15t cubed, we have, for 15, numerical coefficient of 15 is 1 multiplied by 15 and 3 multiplied by 5. For 15t squared, we have also 1 multiplied by 3 multiplied by 5 or multiplied by 15, or 1 multiplied by 15 and 3 multiplied by 5. Then for 20t, we have 1, 2, 4, 5, and 10, and 20. It means 1 multiplied by 20, 2 multiplied by 10, and 4 multiplied by 5. These are the possible factors of 20. And we will find now the common factor for numerical. This is 1, and this is, and then 5. Okay, and now we will take the least exponent of the variables, which is from 20t. So this is t, and then take the product of the greatest common factors of numerical and variables. We have 1 multiplied by 5 multiplied by t, or equal to 5t. And then we will divide each term by the common greatest factor. 15t cubed divided by 5t is equal to 3t squared. And negative 15t squared divided by 5t is equal to 3t. And 20t divided by 5t is equal to 4. We will combine these three terms, taking the signs and multiply by the greatest common factor for the final. 15t cubed minus 15t squared plus 20t is equal to 5t multiplied by 3t squared minus 3t plus 4. And this is our final answer. We will now proceed to example number 7. 10c cubed minus 80c to the fifth minus 5c to the sixth plus 5c to the seventh. And if you will notice, in this example, we have 4 terms. And this is 10c cubed, 80c to the fifth, 5c to the sixth, and 5c to the seventh. Let us take the greatest factor of each term. For 10c cubed, we have 1 and 10 and 2 and 5. For 80c to the fifth, we have 1, 2, 4, 5, 8, 10, 20, 40, 80, and 16. So it means for 80, we have these possibilities of factors 1 and 80, 2 and 40, 4 and 20, 5 and 16, and 88 and 10. And for 5c to the 6, we have only 2, which is 1 multiplied by 5, as well as 5c to the 7, 1 multiplied by 5. And the least exponent of the variables is c cubed. So this is our greatest common factor for the variables. And we will take the numerical factors of each term. All of them have 1 and 5. Combined with c cubed, our greatest common factor is equal to 1 multiplied by 5 multiplied by c cubed, or simply equal to 5c cubed. And we will divide each term by this greatest common factor 5c cubed. For 10c cubed, we have divided by 5c cubed, we have 2. For negative 80c to the fifth divided by 5c cubed, it is equal to negative 16c squared. And negative 5c to the sixth divided by 5c cubed, it is equal to negative c cubed. And last, 5c to the 7 divided by 5c cubed, it is equal to c to the fourth. We will combine all these terms carrying the sign of each term multiplied by our greatest common factor, and that is our final answer. 10c cubed minus 80c to the fifth minus 5c to the sixth plus 5c to the 7 is equal to 5c cubed multiplied by 2 minus 16c squared minus c cubed plus c to the fourth. Number 8 example. 17x to the fifth minus 51x to the fourth minus 34x. Now in this example, we have only 3 terms. And the possible numerical factors of each term is, in this 17x to the fifth, 1 multiplied by 17. And 51x to the fourth, it is 1 and 3 and 17 and 51. It means our factor is 1 multiplied by 51 or 3 multiplied by 17. For 34x, we have 1, 2, 17, and 34. It means 1 multiplied by 34 or 2 multiplied by 17. Therefore, our common numerical factors are 1 and 17. Now the least exponent of each term of the terms in this polynomial is x. Combined with 1 and 17, we have the greatest common factor as 1 multiplied by 17 multiplied by x, or 17x. And by this greatest common factor, we will divide each term in polynomials. 17x to the fifth divided by 17x is equal to x to the fourth, and negative 51x to the fourth divided by 17x is equal to negative 3x cubed, and negative 34x divided by 17x is equal to 2. Combine these three terms, x to the fourth minus 3x cubed minus 2 multiplied by 17x, and that is our final factors. 17x to the fifth minus 51x to the fourth minus 34x is equal to 17x multiplied by quantity x to the fourth minus 3x cubed minus 2. Let us now proceed to example number 9. 12m to the fifth n squared minus 6m squared n cubed plus 3mn. In this example, we have three terms, and we will find the greatest common factor for each term. For letter A, 12m to the fifth n squared, it is 1, 2, 3, 4, and 6, and 12. It means 1 multiplied by 12 is equal to 12, 2 multiplied by 6 is equal to 12, and 3 multiplied by 4 also equal to 12. For 6m squared n cubed, it is 1, 2, 3, and 6. It means 1 multiplied by 6 and 2 multiplied by 3 are all equal to 6. And the last is 3mn, and we have only 2 factors for 3, which is equal to 1 multiplied by 3. And we will get the common numerical factors for these three terms, and we have 1 and 3. Now we will take the least exponent of variables, and we have two variables here, which is m and n, multiplied by the greatest common factor of numerical coefficient, and this is our greatest common factor for each term. It is equal to 1 multiplied by 3 multiplied by m multiplied by n, or simply equal to 3mn. We will divide each term by our greatest common factor 3mn. 12m to the fifth n squared divided by 3mn is equal to 4m to the fourth n. And negative 6m squared n cubed divided by 3mn simply equal to negative 2mn squared, and 3mn divided by 3mn is equal to 1. Again, we will combine these terms, 4m to the fourth n minus 2mn squared plus 1, and multiplied by greatest common factor 3mn. That is our final answer. 12m to the fifth n to n squared minus 6m squared n cubed plus 3mn is equal to 3mn multiplied by 4m to the fourth n minus 2m n squared plus 1 is our final answer. And we have now the last example, 35x fifth to the fifth y squared plus 21x to the fourth y plus 14x cubed y squared. Again, in this example, we have three terms, and we will take the greatest common factor of each term. For 35x to the fifth y squared, the possible factors of numerical coefficient is 1, 5, 7, and 35. It means 1 multiplied by 35 and 5 multiplied by 7 are both equal to 35. And for the next term, 21x to the fourth y is equal to 1 multiplied by 3, no, 1, 3, 7, and 21. So it means 1 multiplied by 21, 3 multiplied by 7 are both equal to 21. And for the last term, 14x cubed y squared is equal to 1, 2, 7, and 14. It means 1 multiplied by 14 and 2 multiplied by 7, they are all equal to 14. And take the least exponent of variables. For x, we have x cubed, and for y, we have only y. So we will multiply by these variables by our greatest common factor of numerical coefficient, and that is 1 and 7. So 1 multiplied by 7 multiplied by x cubed multiplied by y is equal to 7x cubed y. Now we divide each term in our polynomial by the greatest common factor 7x cubed y, and the first term 35x to the fifth y squared divided by 7x cubed y is equal to 5x squared y. For 21x to the fourth y divided by 7x cubed y is equal to 3x. And 4x cubed y squared divided by 7xy cubed y is equal to 2y. Again, we will combine these three terms and multiplied by greatest common factor, and that will be our final answer. 3x to the fifth y squared plus 21x to the fourth y plus 14x cubed y squared is equal to 7x cubed y multiplied by the quantity 5x squared y plus 3x plus 2y, and that is our final answer. And before we end this topic, I want to share with you verse in Bibles from John 16, verse 33. I have said these things to you, that in me you may have peace. In the world you will have tribulation, but take heart, I have overcome the world. Thank you. And if you enjoy this video, don't forget to subscribe, like and share, and hit the notification bell. Thank you very much. Bye-bye.